Hello, second grade. I'm excited to see you again. We are continuing the same work we were working on yesterday, and this is nothing new to you. We've already been tackling this earlier in the year. We're just coming back to revisit because how many of you had a hard time with two-step word problems? I did too. It was tricky. We have to really look carefully at the word problem. We have to think really carefully about what the unknown is. We have to think carefully about whether I'm adding or subtracting or both and which order I'm doing it in. So there's so many things to keep in our minds about doing this work. It's a really good idea to go back and practice doing the same thing so we can get better at it. Because guess what? You're almost third graders and you are gonna have to think through even harder stuff, which you guys are gonna do great with. I'm not worried at all. I'm just gonna miss seeing you every day. Let's dive into some work today. Before we do that, we have to look at our learning target. Let's take a peek. I can solve two-step word problems. Yes, sirree, Bob. We're solving two-step word problems, which is just like yesterday. We just said more than one-step word problems. Today, we're just going to call them two steps, okay? And we are going to solve them, but we are going to solve them in different ways. Just like yesterday, we were using our base 10 blocks. We were using number lines. Some of us were using equations. And guys, I only showed you a couple things that I saw from each of you. There are so many more ways out there. Isn't that awesome? I love seeing new ways of solving problems because it makes me think, you know what? I think I might get it. I'm not that far off. It helps me feel better about myself as a learner. How about you guys? Whew. It's always nice to see my work up there and to know that I'm doing the right thing and making sense of something that's tricky. So we're going to continue showing some of those strategies, and I'm excited to see us make sense of these problems. The first one is a humdinger. Let's read it. Lee's fish tank has 24 goldfish and some silverfish. There are 59 fish in the aquarium. Lee puts in some more silverfish. Now there are 51 silverfish. How many silverfish did he put in the tank? Oh, dear Gussie, guys, this is a humdinger. I had to do this work before I could show you because I knew if I didn't do it first, I was going to get really confused trying to teach you. His fish tank has 24 goldfish and some silverfish. And there are 59 fish in the aquarium. Can I have all of you write the equation that might match that work? Because what do we not know? Yeah, we don't know how many the some silverfish is. So what would that equation look like? What did you put first? 24 plus box equals 59. Okay, so what does that 24 represent? Our goldfish. What does our box represent? Our silverfish. And 59 is all the fish in that tank. Okay. Then what? Lee puts in some more silverfish. Now there are 51 silverfish. How many did he put in the tank? Okay, so we don't know this. It's gonna come over here. Ooh, let's just put let's not put a top on that yet, right guys? Because, ooh, we don't know that. But that's not our unknown, is it? What are we having to figure out when we solve this, friends? Ooh, I need my loopsy tape. Yes, we're not solving for how many silverfish were there at the beginning, are we? No. We are having to figure out how many more he put in. We don't know that. So we have to figure out the first one before we can solve the next one. Now, guys, we already know how to do that, don't we? Because we've done it before. We did it yesterday. So let's go ahead. We know that he added some more, and we don't know that. That truly is our unknown. And that's how many silver fish he has total. I'm doing this with you guys because I'm going to be honest. It took me some brain power to figure that out. How about you? Okay, so we need to figure out these 2 steps, and when we're done, we're gonna write 1 equation to match. How's that sound? Good? Okay, so let's figure out what's gonna go in this first box first. Take a moment, and I want you to solve for this work. What are you starting with? Okay, and how are you gonna get there? What are you trying to get to? Trying to get to 59, okay? So you're adding to get to 59. What are you doing? You're trying to 59. You're subtracting to find that unknown. About 30 more seconds, friends, to find just this first part, okay? Just the first one. Okay, so what did you do? You added 3 10s, okay, and then what did you do? Added some 1s, okay. Oh my goodness, all right, let's come together. Oh my. Okie dokie, got a couple friends doing some different things. Starting at 24, 3, 4, 1, oh, not 20, oh my goodness. This oopsie tape is getting a workout for me, isn't it, guys? Holy guacamole. I love my oopsie tape. Have I told you all that before? I use it in my classroom every day because, well, frankly, everybody makes mistakes. Okay, so I have my 24. There we go, second try. Got my 24, and what am I trying to get to? 59. Okay, so what did you do to help you do this? You wrote 50 and 9 down here. Okay. So to get to 50, what did you do? 20, 30, 40, 50. Okay. And what did you do for your 1s? 4. Okay. 5, 6, 7, 8, 9. Okay, so where's your unknown in that picture, in that model? Alrighty. Alrighty-roo. And what is your unknown? 30 and 5, also known as 35. Wiggle waggles? Agree? Disagree? Oh my goodness, I had everybody's giving me that they got that answer, but I know by looking at somebody over here that they did not solve it the same way. They used a different model, but they also did something really crazy. What did you do? You started with 59 and took away 24 to find that unknown. Okay, because you know you can subtract to find that change, can't you? So where did you start at? You started at 59. I gotta slow down. I'm so excited. I start to talk all over myself when I get excited. And you did what? Took away 20. All right, and then what did you find out? That was 39, okay? Because, 5 10s, take away 2 10s equals 3 10s. And then what did you do? Took away 4, so 38, 37, 36, 35. And got the same answer. And here's that 24. So we have our first spot. So where is this 35 going to go on the next piece of work? In that next equation. Okay. Now, 35 is over here. Now what am I going to do? Find out what's going to go in this box, and that should help me find my unknown. You may go ahead and begin. Show me how you might go about solving that work. You may go ahead and start. Erase that so you guys don't think it's a 1. 351. So where are you starting on your number line? Okay. So you're starting at 35 and you're counting on. All right. So where's your unknown in that work? Because where are you stopping? All right. You're using your base 10 blocks again? Okay, so you're at 35, and then what are you going to do? You're taking away using your base 10. Okie dokie. All right. Oh, that's so awesome. All right, friends, let's come together in 5, 4, 3, 2, 1, and done. All right, I'm going to go purple again, and I want us to think. So this is our step 1. And then how did you use your base 10s to show step 2? I should have put it right next to it, and I didn't. Okay, so you started with 51, and you took away what? 35. Okay, so what did you have to do first? Okay, so you crossed off that, and you made 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I'm going to write that 51, take away 35. That's your action that you're using, right? So you're taking away 3 10s, 10, 20, 30, 1, 2, 3, 4, 5 ones. And what did you have left? 1 10 and 6 ones. 1 10 and 6 ones. So how many silverfish should he add to his tank? He added 16 silverfish to his tank, didn't he? So if I'm using my base 10s, I could add. I can start with start with what I knew. I'm trying to get to what I also know, so I'm adding to get to that, adding my 10s and then my 1s. But then I can also start with the part I know and take away the part I know to find that unknown part. Those base 10s can be used a couple different ways, can't they? And then with that base 10, or that number line, what'd you do? So again, this is our step number 1. So step number 2, what did you do? You added this time. So what did that look like? Starting at 35, okay. Jumping 10. Why just 10? Okay, so if I jump 20, that would get you to the 50s, but it'd be 55. That's too much, isn't it? Okay, then what? Made a jump of 5, and why is just a jump of 5? Oh, that 10 is a friend. Oh, yeah, 10 is a friend. And then what? One more, because you're trying to get to 51. Oh, you're gussy, guys. So where is your 35 that you started with? Where's the 51 silverfish total? So where is the amount of silverfish that he added? And how much did he add? 10, 15, 16. And there's that unknown. So look, guys, I didn't put them together. I should have. But using our base 10 and then using our number line, what do you notice? I'm going to mark 35 in here. What do you notice about these two strategies? They did kind of use a combination of addition and subtraction. Why do you think they did that? But the ones from yesterday, we didn't really see a whole lot of adding and subtracting being moved around. Yeah, it's a little tricky, isn't it? We have our change that's unknown this time. Our result was unknown yesterday, but when that change is unknown, we don't know how many more or how many less they get. That makes things tricky. That adds a little extra difficulty to our work. So sometimes we add to get to the part that we know, or we take away to find what we don't know to make it just a little bit easier. And that might even change. You might use addition for the first part and subtraction for the second part, or vice versa, depending on what works for you. You got to use what makes sense to you so that you can be an efficient solver. Remember, that means that we're quick, but we are accurate. And both of these got that unknown, didn't they? Yes. So what would our equation be if we were going to write one equation to match this work? What would it be? Help me out. 24 plus, plus, we don't know, equals 51. But what did we know that helped us solve this? We knew that this equaled 59. And that's what made this solvable. If we had two unknowns with no other clue, we would not have been able to make sense of this problem. So this was super helpful. Knowing that 59 were in the aquarium to begin with, we didn't know how many silverfish were there, but we did know how many were there total. And that helped us make sense of this work. Whew. I think the second one's a little bit easier today. I'm going to work your brain really hard and then give you a little bit of a break before you did your independent practice. Let's take a peek at number 2. There were 35 apples on the table. 17 of them were rotten and thrown away. 9 apples were eaten. How many apples were still on the table? There were 35 apples on the table. 17 of them were rotten and thrown away, and 9 of those apples were eaten. How many apples were still on the table? I'm just going to give you a quick few moments to write an equation to match the story. What would you write? And what is that unknown going to represent? Okay. All right, friends. Thumbs in front of your tummies when you're ready. Eeny, meeny, miny, moe. Get your tiger by its toe. If y'all let them go. Tell me, what did your equation say? I'm seeing the same equation on all these papers. How about you guys at home? You ready? Okay. What'd you do? 35 apples on the table. Okay, then what? 17 were rotten and thrown away. So why did you put a minus sign? Because they were in the garbage. Then what? We ate 9 in our tummy. We're not getting more. They're going away. Equals box. Oh, man. You guys are not going to have any problem at all. I just know it. Show me. Take a few moments to yourself and show me how you're going to work on this problem. Remember to ask yourselves and always go back and double check. Do I have my 35 in my model? Am I showing where my 17 is being taken away? Am I showing where my 9 is being taken away? And can I find that unknown? Okay, go ahead and you may begin. I'm going to keep talking, so I want you all to pause me and then resume me when you are ready. Remember to have all the numbers in your model, okay? All right. Whew. All right, base tenor. What'd you do? I love having this base 10 on there because it helps me see it. And looking at benchmarks, I know that base 10 is still tricky for us sometimes, isn't it? So what did you start with? 10, 20, 30, 1, 2, 3, 4, 5. Okay, so there's your 35 apples. Then what? Okay, so you're going to take away 17. And did you just start crossing those off? All right, so you broke that 10 into 10 ones. So if I'm making 35 and I'm breaking up a 10, then I should have 20 and then 15, right? Because I'm trading this 10 for this 1. So 2 10s and 15 ones is the same as 3 10s and 5 ones, right? Okay, so I have that. Now what am I going to do? Cross off 17. 1, there's your 10. 1, 2, 3, 4, 5, 6, 7. All right. So when you did that, 35, take away 17, what did you have left? You had 1 10 and 8 ones. All right, then you take away 9. You don't have enough, do you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what are you going to do? 1, 2, 3, 4, 5, 6, 7, 8, 9. And what do you have left? You have 9 left over. So how many apples are still on your table? 9. Okay. All right, now, number line. What did you do with that number line? One big number line, okay. Where'd you start? 35. Okay, then what did you do? Took away 10. I got 25. Why 10? From that 17. Okay, then what? Okay, so you broke 7 up into 5 and 2. And why 5 and 2? You're taking away that 5 to get to 10 is a friend. Yes, yes, yes. And then 2 more gets you to 18. Okay, so there's your 17 that were rotten. Then what? Took away 8. Why 8? Okay, that gets you to that 10. And then 1 more. So you decompose the 9 into 8 and 1. And that lands you on 9. All right. Same answer. Same kind of work, right? Can I share our equation? Our friends that did an equation. I'm really excited to think through this because they did something very unique that was a little different than these two strategies. Let's see if you can figure out what was so different. Okay. Oh, I don't want to use that one. I want to use, I love getting just the right color. Okay. All right, equations. Where did you start? Okay, so you started at 35. Okay, you took away 5 to get to 30. All right. 30, take away 10 to get to 20. And then 20, take away 2 to get to 18. Okay, so what number are you taking away if you take away 5 and 10 and 2? Okay, there's that 17. There's that 10. Okay. All right, and then what did you do? Landed on 18. But you said, I know, and I'm going to put like a little think bubble here. This is smart. 9 plus 9 equals 18. So 18 take away 9 equals 9. You didn't actually subtract on that last one, did you? Why not? Because it was a known combination. Guys, how is the work of these and this similar? And how is it different? Lean back a little bit. Okay, they both took away 17. Absolutely. This one even broke it up into 10, 5, and 2. So these two are similar that way, aren't they? Okay. This one had to decompose a lot, right? Had to break up those 10s. And this one broke up 10s too. They did a little different way. This one added. So instead of having to break up a 10 and do those 10 ones, could have added, but this one worked, didn't it? Broke up to 8 and then the 1 to get to 9. But this one did the 9 plus 9 equals 18. So 18 minus 9 equals 9. Guys, this is hard work, and you all are so smart. Remember that I want you to be using the strategy that works best for you. Tomorrow, our work is not going to be 2-step word problems. It's just going to be tricky. We're going to have some thinking. We're going to do some thinking together, and we're going to have to do some thinking separately. So I cannot wait to see what we do with tomorrow's work. See you later. Have a good day.